Okay, I'm going to be answering every question that's ever been asked about vectors, and the first part of this video is just going to be a couple of questions just on column vectors, so nice and easy. These ones are going to be tough. These are probably going to be some of the toughest things that you will do in GCSE, really there for the people that are aiming for that grade 9. So column vectors, just a couple of questions here. It says the vector A and B are shown on the grid. On the grid, draw and label the vector minus 2a. So if it's minus 2a, that means that the minus means it's going to flip the length and it's going to be twice as long, and it can be anywhere that you like on the grid. So if I'm going to flip the direction and make it twice as long, you'll see how it's kind of going 1 across and 2 up. I'm now actually going to go instead 2 left and 4 down. So if I start from here, I'm going to start here, I'm going to go 2 left and 4 down, and it's going to end up at this bit here. So if I just close that, and I'm going to put this direction here, this is minus 2a. So it was going that direction, it's now going twice as long and in the opposite direction. And then it wants me to work out a plus 2b as a column vector. Well, first of all, a is equal to 1 across and 2 up. That's 1 across and 2 up. And b is equal to, well, it's going 1 across and it is going 3 down. You can see here it's going 1 across and 3 down. Now, if you want to add them together, you can actually just do a plus 2 lots of b, which is 1 minus 3. So that is a 1, 2, not a fraction, that is a 1, 2. If I double the b vector that we get there, we're going to get 2 minus 6. Now, 1 plus 2 is equal to 3, and 2 minus 6 is equal to minus 4. Now, you could do that on the grid as well, geometrically. You could do a plus 2b. This would be an a, and then 2b would be 2 of these together. That's 1b, that's 2b. And overall, you'll see that this vector that we've got is 3 minus 4. So that's kind of the geometric sense of what is going on. So we'll double check we've got this one right. I know that the 2a one is drawn correctly, and then I've got 3 minus 4 for this one down at the bottom. Okay, let's have a look at this one. Very simple. It wants us to do 2a minus 3b as a column vector. So I'm going to do 2 lots of 3, 4. And then I'm going to do minus 3 lots of 5 minus 2. Now, all you've got to do here is just be very careful when you multiply by the negative. So I'm going to do this one multiplied by 2. That's going to give me 6 and 8. And then I can leave the negative outside and times them by 3, or I could multiply it in. I'm going to leave the negative out, and I'm going to just times the middle numbers by 3. So it's going to be a 15 and a minus 6. Now what you need to do is 6 minus 15. 6 minus 15 is minus 9, and you can check it on the calculator. And then 8 minus minus 6, that's actually 8 plus 6, which is 14. But just to kind of prove that to you, if I do on my calculator very carefully, 8 minus minus 6, you do get 14. So we're looking for minus 9, 14 for this one, minus 9, 14. Now, I'm actually going to include this all in one video. I'm going to keep going, and we're going to do all of the vectors in one video, because I think that was so short there. So it says here that OABC is a parallelogram, OA is equal to A, and OC is equal to C. These are the really hard questions, by the way. X is the midpoint of the line AC that we've got here. So there's my line AC, and I'm going to put a point in the middle here, is going to be X. OCD is a straight line, so that OC to CD is K to 1 as a ratio. Okay, well, let's just extend this line OCD. I don't really know how long it's actually going to be, but I'm going to put D over here somewhere. And it says here that the vector XD is given as 3C minus a half A. So I'm going to connect these two things together. This is my XD that we've got here. And I think that's definitely going to be the thing that I'm interested in this question. So I have been told what XD is, which means I'm going to try and find what XD is in the diagram. Now, the way I'm going to try and find that is by doing this pathway, which is equivalent to the XD pathway. So they have told me that XD is equal to 3C minus a half A. I'm going to find XD in a different way. To find my vector XD in a different way, I'm going to do XC plus CD. That is basically what I'm going to be doing. This is my method for the question. So to try and find out what XC is, well, XC is a half of AC. So I'm going to begin by finding out what AC is equal to. Well, AC is equal to going backwards along here and then forwards along here. Backwards along here is minus A, and that is a plus C. So that's going to be a minus A plus c. Now xc is just a half of that because it's a midpoint. So the xc that we're going to get is a half of this, which will be minus a half a half of that one, and it's going to be a half of c. Now I just need to figure out what CD is going to be. Well, I know that CD is going in the direction of C because this one is C, so it must be going in that same direction. I'm just going to give it a letter, some kind of multiple. Now I would have used K, but there's a K here. I would have used C, but that's here. These are the letters I usually use for a constant. I might have used X, but it's here, so I'm just going to use the letter Y. I'm just going to do a little side note here. Y is not a vector, Y is a constant. And it's just saying I'm taking C and I'm multiplying it. It must be in the direction of C because it is in this straight line that we've got here. So we know that XD is the thing I'm looking for. We know that it is XC, which is minus a half A plus a half C, and plus CD, which is plus YC. So this that I have used here is now being used down here. And I also know that it's equal to 3c minus a half a. So I'm going to replace the left-hand side with 3c minus a half a is equal to minus a half a plus a half c plus yc. Now what you can see is that the half a's luckily cancel. And what we get left with is on the left-hand side we have 3c. And on the right-hand side, if I factorise, we're going to get a half plus y c. So by comparison, we should be able to see that 3 must be equal to a half plus y. So coming along here, we're now going to say that 3 is equal to 1/2 plus y. Now this is non-calculator, so I'm going to subtract a half from both sides, and I get that 2.5 is equal to y. Now this is telling me that if this one is c, this one is 2.5c. So we've now worked out that this vector running along the bottom is 2.5c. So let's see what the question says. Find the value of k if the ratio of this one to the ratio of this one is k to 1. So the ratio of this one is 1c, and this is 2.5c. So I'm now going to say that the ratio of OC to CD, well, we said that that one is 1c and this one is 2.5. So just getting myself a little bit more space here. I'm now going to try and make it so this side is a 1. I'm going to divide both sides by 2.5. I'm going to do 1 divided by 2.5, and that would be a 1. 1 divided by 2.5, if I multiply the top and bottom by 2, it would be 2 divided by 5. So I get 2 divided by 5 to 1, and that means that k is equal to 2/5. A very, very, very difficult question. So all I did here, 1 divided by 2.5, just in case anybody gets stuck at that point, 1 divided by 2.5. If I double the top and I double the bottom, I get 2/5, which obviously you're allowed to do with fractions. Okay, so hopefully we've got that k is equal to 2/5. Yep, there it is there. Okay, so continuing with this, here is the next problem we're going to have a look at. Okay, a super tough question, and really there's just so many different things you need to do for this. It is a lot for 5 marks. So we've got a triangle. They tell us that this is a straight line, this is a straight line, M is the midpoint, OA is A and OB is B. So we're just going to get started and label that we know this is A, and we know this whole vector along the bottom is B. They tell us that OP to PM is 3 to 2. So that means that this is 3/5 and this is 2/5 of the whole line that we've got here. And we're definitely going to have to use that at some point. It wants us to work out the ratio of ON to NB. Well, the whole point in these things is to try and find out ON in like 2 different kinds of ways. And if you can find it in 2 ways, that usually will allow you to compare things and see what kind of ratio this is compared to the whole thing. So we're going to find ON in 2 ways. The first way that I'm going to say is that ON actually is just some multiple k of the vector B, because ON is just some fraction of this whole thing. So we're expecting k here to be a fraction. Now the other way that we're going to find the vector ON, which is just from here to here, is we're going to go OA plus AN. So we're going to do OA plus AN. Now the OA part is obviously super easy, it's just A. But the AN is where things are going to get a bit harder. So we also need to think, how are we going to find AN? How to find AN. So to find AN, I'm going to try and think about how I could find out what AP is. And to find AP, I'm going to have to use AM as well. I mean, there's just like a lot of different things to do. I think I'm going to find AP by going AO and then OP. So let's just get as much stuff as we can going in this question and kind of see how we can pull it all together. So first of all, I'm going to need to use the vector AB, which is minus A plus B. These are crazy hard. So even if you just get some of the marks, it's better than getting none of them. Now I'm going to find out the vector AM because they've told us that. So that will also give you a mark. It's going to be a half of that. So it's going to be minus a half A plus a half B. Now that I've got those ones, I'm going to try and find some other kinds of things. I'm going to try and find out what OM is equal to. That will help me find out what OP is, and then I can find out AP by doing this. So now I know that that's what AM is equal to. I'm going to find OM. OM is going to be equal to A plus AM. So that's A plus AM, which is minus a half A plus a half B. So that is a half A plus a half B. Now I can find out what OP is because it's 3/5 of that. So OP is 3/5 of a half A plus a half B, which is 3/10 A plus 3/10 B. Now remember, I'm doing all of this so I can eventually find out what AN is. So now I'm going to find AP. So AP is going to be equal to minus A plus OP. So that's minus A plus OP, which is 3/10 A plus 3/10 B. And that is, well, I've got minus 1A plus 3/10. That is minus 7/10 A plus 3/10 B. And now I think I can say that AN is equal to some kind of multiple of AP. Because APN is in a straight line, whatever AP is, I can multiply it by something to make it AN. So I'm going to multiply it by x. I'm going to say that it is x multiplied by minus 7/10 A plus 3/10 B. And I'm hopefully now going to give myself some more space by grabbing all of this. I'm just going to resize this and make it nice and small because this is a crazy question with loads of working in it. So now that I have this AN that's here, I have this. So I actually can just go straight in and find out what ON is equal to. So somewhere over here, I'm going to say that ON is equal to OA, which is A, plus the AN that we've just worked out, which is x brackets minus 7/10 A plus 3/10 B. And I also know that ON is equal to KB. So I'm now going to write this part, which is my ON here and here. I'm also going to put that on the left-hand side where ON is. So I get KB is equal to, I'm going to get A plus, or not plus when I expand the brackets, I'm going to get these multiplied, which is minus 7/10 XA plus 3/10 XB. Now when I have these two things, I can say that this side must be the same as this side. So anything to do with A over here must be the same as A over here. And if you look on the left-hand side, there are no A's at all. So I can say on the left-hand side there are no A's. On the right-hand side, there is a 1 minus 7/10 x. This is 1 minus 7/10 x. And this is me comparing the A vectors. So this tells me that 1 is equal to 7/10 x, which means that x is equal to 10 over 7. Now, I'm not even going to be sure I can fit this in. If I'm now going to compare the B vectors that I've got, on the left-hand side there is k, and on the right-hand side there is 3/10 x. So k is equal to 3/10 multiplied by 10 over 7. I'm going to have to zoom in for this. Haven't had to do this on any questions so far. So k is equal to 3/10 multiplied by x, which we have just worked out as 10 over 7. That's 30 over 70, or 3 over 7. So this is telling us that this is 3/7 of the whole thing. So ON, because we said it is KB, ON is 3/7 which means that between n and b is going to be 4/7. So the ratio is 3/7 to 4/7, which is the same as 3 to 4. I mean, this question is crazy. So it's kind of not even sure why you're doing all of these things, and it comes to this stage here. This is like A-level difficult. I guarantee if I gave this to people in my year 12 or my year 13 class, the majority of them are going to struggle, even if they're aiming for A's and A stars. So let's just double check we did get it right. We get the 3/4, and the mark scheme is just hilarious. I mean, look at that compared to what we've done here. I mean, you couldn't even tell from the mark scheme how to do this. Okay, here is another question for us to have a go at. Equally as difficult, and kind of with some of the same ideas, and they sort of lead us through it. I mean, this is a 6-mark question. This is a big question that we've got here. So it says that CD is equal to A. I'm going to label that on the diagram. DE is equal to B, and I'll label that on the diagram. I might change it later when I get to part B though. And it says that FC is A minus B. Express FE in terms of A and or B. Give your answer in its simplest form. So this one isn't too bad for 2 marks. Everyone should be able to do this. You just want to find out how can you get from F to E. Well, you go up here, then along here, then down here, which just means it is going to be the A minus B plus the A plus the B. The B minus B and the B cancel each other, so you just get the answer 2A, which is fine for that first part of the question. Here's where things get kind of crazy. I mean, this video is going to be long, but hey, we're doing all the questions on vectors, so it's unsurprisingly going to be long. It says that M is the midpoint of DE. So I'm actually going to shift this. I'm going to change it now as this is a half B and this one is a half B as well. X is the point on FM such that Fx to xm is n to 1. CXE is a straight line. Work out the value of n. I mean, I know people hate these questions, but I can see why they're tough. I do like vectors, but they are not easy. So the same strategy is going to kind of come in like we did in the previous question. We're going to try and find fx in 2 different ways. So we're going to find fx in 2 ways. The 2 ways that we're going to find fx are going to be like this. One of the ways of finding fx is going to be doing this pathway. We're going to say that it's some fraction of fm. The other way we're going to do it is going to be fc plus cx, which is some fraction of ce. So I'm going to try and say my 2 ways are going to be is that fx is going to be some fraction k of fm, and my other way of doing this is that fx is going to be some other fraction of c, not ce, it is going to be, let me say that again, it is going to be fc plus some other fraction of ce that we have. Now we just need to get going of working out these 2 different ways that we've got here. So I need to find out what fm is equal to. Well, fm isn't going to be that difficult to find because it is just going to be this plus this plus this, or we could say it's fe minus em. So I'm probably going to do the second one. I'm going to say that fm is equal to fe, which is 2a, along here, and then we're going to go backwards. We're going to do minus a half b. So with my first way, and I'm going to just sort of draw the line down here, this is all for part B of the question. I'm going to say now that fx is some fraction of this, so k lots of 2a minus a half b. Now I'm going to do the second way, so I'm going to try and figure out these things. Now fc is easy. I need to figure out what CE is. Now CE is going to be my next thing that I'm going to try and find out. I'll tell you what, I'm going to highlight this in green now so I know that that's one of the things that I'm going to use. So I'm going to find out what CE is. CE is going from here to here. I'm going to say that it is A plus B. Really easy. C to E is just A plus B. A plus B. So I can now find out what fx is equal to. I can use this information at the top. This is my way 1, so I'll draw a line under it. This is my way 2. It's fc plus xce. So fc is a minus b. So it is a minus b plus x lots of a plus b. Now I'm going to highlight that in green as well because that is my second way of finding this. And I'm going to take all of this stuff I've got here, I'm going to shrink it down because I know I'm going to need a little bit more space for this next part of the question. So now that I've got those two bits, I'm going to compare them. I'm going to say that k 2a minus a half b is equal to a minus b plus x lots of a plus b, this part that we've got down here. I'm just trying to figure out if I can get some more space. I'm going to do this instead, is what I'm going to do. So plus x lots of a plus b. Okay, expanding the brackets, I get 2ka on this side minus a half kb equals, let's do the a parts together. I'm going to get a plus xa, a plus xa, and then I get minus b plus xb. Now when I compare the a parts, on the left hand side I have 2k, and on the right hand side I have this, there is 1 plus x, lots of a, I get 1 plus x. When I compare the b parts, on the left hand side I get minus a half k, and on the right hand side I have got minus 1 plus x, lots of b, minus 1 plus x. Now I need to solve these equations simultaneously, so I'm going to make x the subject of this one that we've got here. And when I make x the subject, I add 1 to the other side, so I get 1 minus a half k equals x. I'm now going to take this thing that I've got here and I'm going to substitute it where x is. So taking that equation that's at the top, I get that 2k is equal to 1 plus 1 minus a half k. This is a non-calculator paper, so 2k plus a half k, that's 2, what have I done there? That's 2 plus a half, that's 2.5k is equal to 2, which means k is 2 divided by 2.5, double the top and bottom, which is 4/5. I could find out what x is, but actually I think k is the one that I was looking for, because I said that fx is kfm. So this line here is 4/5 of the whole thing. So this is 4/5. Let's do this in a red color. This is 4/5, which means this part must be 1/5 because it's the whole line in total. So the ratio is 4/5 to 1/5, and then we can simplify that ratio. So we're going to say that it is 4/5 to 1/5, which simplifies to 4 to 1, meaning that n is equal to 4, because in the question it said work out the value of n, and n was in this form that we had here. I mean, I don't think you could understand this from the mark scheme. It is kind of crazy, which is why I'm hoping these videos are really going to help you. And like I said, this is really if you're aiming for that grade A star that we've got here. Okay, we've got another one to do with ratio of lengths, and it says OXYZ is a parallelogram. OX is equal to A. Where is X on here? I can't even see it. OX is equal to A. OY is equal to B. Well, that's also telling me some other things that I know here. I know that this is going to be A because it's a parallelogram, so they're parallel and opposite to each other. So I could label that on the diagram now. I might actually just put that on straight away. And it says P is the point on OX such that OP to PX is 1 to 2. So that means that this is 1/3 and this is 2/3, ratio of 1 to 2. R is the point on OY, so it's the ratio of OR to RY is 1 to 3. That means in this line that we've got here, that would be 1/4 to 3/4. I'll put that line in red so that it's clear that the fractions are referring to that line, and I'm going to put this line here in blue so that it's clear that those ones are referring to that line. Work out in its simplest form the ratio ZP to ZR, and you must show all your working. So we're going to do the ratio of ZP to ZR. Well, I think this is going to be the same kind of thing that we've done. We're going to try and do the journeys of ZR in like a couple of different ways. Because, what does it want? ZP to ZR, great fun. Okay, I'm going to say that we're going to try and do, in this line that we've got here, we're going to want to work out the journey of ZR in a couple of different ways. So one of the ways is just going to be like this, and I'm actually probably not going to do it 2 ways. I'm actually going to then do ZP, and then I'm going to say that ZR and ZP are parallel to each other. So I'm going to start off by finding out what ZR is equal to. Now ZR, I'm going to do this pathway. Instead of going here, I'm going to go ZO. Oh no, I'm not. I'm going to go along here and along here. I think that's actually going to be my best route. I'm going to go here and then I'm going to go back along here. So ZR is going to be A as we move along here. And then it's going backwards 3/4 of B. So it's going to be minus 3/4 B that we've got. Now I'm going to try and find out what ZP is, but using like a different, like how am I going to get from Z to P? So ZP that we've got, ZP, well, I think I can probably do a weird route. You're going to think it's mad going this way, but I don't want to use these sides because they're a bit complicated. I'm going to go A minus B plus 1/3 A. So I'm going to go A minus B plus 1/3 of A. So that is A to the right minus B plus the 1/3 A that is along the bottom. And if I simplify that, A plus 1/3, 1 plus 1/3, that is 4/3 A minus B. Now I know something. I know that ZP is ZR in the same direction as ZR, but it's just been multiplied by something. So I'm going to put these two vectors that I've got here into this. ZP is ZR that's being multiplied by some value K that we've got there, and then we'll use that to reason with what's going on. So we get that 4/3 A minus B is equal to K lots of A minus 3/4 B. Expanding the brackets on the right hand side, we get KA minus 3/4 KB. Well, comparing the A parts that we've got here, we can see that K is equal to 4/3. And when you compare these parts, if K is 4/3, 3/4 times 4/3 does give you that minus 1. So you get minus B is minus 3/4 times 4/3. So it does work. So K is 4/3. That means that ZP is 4/3 the length of ZR. So ZP is 4/3 the length of ZR. And we want to find out the ratio of ZP to ZR. So that means that if I have this, this is 4/3 and this is 1. So ZP is 4/3 and ZR is 1. So if I times them both by 3, I get 4:3. So that last bit just kind of finishes up here. So my ratio is 4:3. It's a little bit different to the previous question, actually, because of the fact we had these both in the same lines. And it's because they gave us both of the ratios. In this one, we only had the ratio of one of the lines, which is why we had to introduce the X and K. And in this previous question, we only had the ratio of one of the lines, so we had to introduce the K and the X. So if they ever give you the ratio of both of the lines, like we did in this one here, you actually don't need to do it in quite as complex a way. Let's double check we've got it right. It is 4:3, a very, very difficult question. Now this one isn't so bad actually, so let's just dive in and kind of see how this works. It's not so bad because they give us a lot of ratios, so it kind of has similar vibes to the previous one. It doesn't even need us to do any proving, it just wants us to work out this vector DE. So all of the information they've told us is on the diagram already, and it says that D is the point on OB such that OD to DB is 2 to 3. Well, that means on this line, which I'm going to do in blue here, I'm going to do that a little bit neater, is the fractions are going to be 2/5 and 3/5. So let me just zoom in so I can write that neatly. This is going to be a 2/5 section, and this is going to be a 3/5 section. And then it says E is the point on BC. So E is the point on BC such that the ratio is 1 to 4. Now that means that this is going to be 1/5 and 4/5. That's how we would have it in the correct ratio of 1 to 4. And it wants us to work out the vector DE in terms of A and B. So the vector that we're aiming for here is this one. And we're going to do that by doing this journey here, okay? So the vector DE that we're going to do, let's do it all in black this time so that it's not going to mix up with the blue and the red. It is going to be 3/5 of this one, which is OB, plus 1/5 of this one, which is BC. So all I need to do is find out what OB and what BC are, and then I'm good to go. So let's find out what OB is. OB is how you get from here to here. It is simply just A plus B. Now I'm going to work out what BC is equal to. So how do I get from B to C? Well, it is minus B minus A plus 3B. So it is minus B going backwards along there, then minus along A plus 3B. So that is minus A plus 2B. Now putting that all together in this one that we've got here, we can say that DE is equal to 3/5 of A plus B plus 1/5 of A, or of minus A, sorry, because it's coming from this part that we've got here, of minus A plus 2B. So we have 3/5 A plus 3/5 B minus 1/5 A plus 2/5 B. And of course you can do these in your calculator, but these are pretty easy ones to do. 3/5 minus 1/5 A is 2/5 A, and then I've got 3/5 B plus 2/5 B, that's 5/5 B, or just plus B. So we get that DE is equal to 2/5 A plus B. Let's hope we've got this one right. There is the 2/5 A plus B. Significantly easier than the previous question. Okay, so this time, this is another kind of provy problem-solving kind of one. It says that OAN, OMB, and APB are straight lines. Here's an interesting bit. AN is equal to 2 lots of OA. M is the midpoint of OB, and they've told us that OA is equal to A. So I'm going to say that this is A, and they told us that AN is 2 lots of that, so I can say that it's 2A. And they've told us that OB is equal to B. Well, this is the midpoint, so I can say this is a half B, and this is a half B that we've got here. AP is K lots of AB. So we've already got this relationship about AP is K lots of AB. So I'm definitely going to want to use that. It then says, given that MPN is a straight line, find the value of K. So in this particular thing that we've got here, because it's a straight line, I know that this vector between M and P and this vector between P and N, they're going to be in the same direction. They're going to be multiples of each other. So I'm just going to jot that down at the top. I'm going to say that the vector MP is in the same direction as either MN or PN, but I'm going to just go with PN that we've got here. So let's begin by thinking, how are we going to do these journeys? We need to find out what MP is. Well, to get what MP is, actually I think the easiest one is probably going to be MN. So why don't I, instead of doing MP, I've changed my mind halfway through the question. I'm going to say MN because it's just easier to do. And this is how you should answer questions. So MN is equal to go from here to here, that's minus a half B plus A plus 2A. So that is minus a half B plus A plus 2A. Well, let's put the A's first. That's 3A minus a half B. Now, if I want to find out what PN is equal to, I need to find out what PA is going to be equal to. Well, before I do that, I need to find out what AB is equal to. AB is equal to minus A plus B. So that's minus A plus B. And then they've told us that AP is K lots of this. So AP is K lots of minus A plus B. But we want to find out what PN is. So I'm going to say PN is PA plus AN. So PN is equal to PA plus AN. Now PA is this one that we've got here, but in the reverse direction, so it's going to be a negative. It's going to be minus K minus A plus B, and AN is 2A. So expanding these brackets, the minus K times minus A is positive KA. We then get minus KB, don't want to underline the K because it's not a vector, plus 2A. Now we know something. Because they are in the same direction as each other, we can say that they are multiples of each other. They are multiples of each other. What I mean by that is that MN is some multiple of this one. So I'm going to say that MN is some multiple x of PN. So mn is 3a minus a half b, and that is some multiple x of this one that we've got here. So that is going to be, or maybe I should put the x on the other side. We'll see how this goes. We're going to say that it is a k plus 2a. So there is a ka plus 2a, and then we get a minus kb. So looking at the a parts that we have, on the left hand side we have 3, on the right hand side we have kx plus 2x. Okay, we're now going to look at the b parts. So the b parts that we have here is that minus a half is equal to minus kx. Okay, well that's good, because that tells me that a half is equal to kx, which means I can put that in here. So I'm going to put that into this equation, and I get that 3 is equal to a half plus 2x. So 3 minus a half divided by 2, yep, I'm going to be lazy now. 3 minus a half divided by 2, so x is equal to 1.25. So x is equal to 1.25, which then means I can go over here and say that a half equals 1.25k. So I'll do a half divided by 1.25. So I'm going to do a half divided by 1.25, and I get that k is equal to 0.4, or 2/5. I could have put the x on the other side. I think that might have made it a little bit easier, but you can do it either way. And this is me just doing the questions in live time, so you can kind of see the way that I end up with them. We get that k is 2/5, or equivalent. 0.4 is the same as 2/5. Okay, this one is actually not so bad, even though it's a proof question. It says DEF is a triangle, P is the midpoint of FD. Great, I can see that, and Q is the midpoint of DE. FD is equal to A. Well, immediately I'm just going to say that this is a half A, and that this is a half A because it's the midpoint, and FE is equal to B. We want to use a vector method to prove that PQ is parallel to FE. So if they are parallel, then FE is going to be some multiple of PQ. This will be what it's equal to if they are parallel, because they'll be vectors that are going in the same direction, but the k just means that they won't necessarily be the same length. Well, I've already got what FE is equal to, so I just need to find out what PQ is equal to. Well, PQ is equal to PD plus DQ. Okay, well the PD part is easy because that's just a half A. So that means that it is just going to be a half A. But DQ is a half of DE. A half of DE. So PQ is a half A plus a half of DE. Now DE is minus A plus B. Minus A plus B, which is a half A minus a half A plus a half B. The minus a half A and the half A and the minus half A cancel, and we just get that PQ is equal to a half B. So now what we can say is that PQ, or I could actually say, the alternative thing I could have said at the top, either this, or I could say that PQ is some multiple of FE. It doesn't really matter if they're parallel to each other. And we can see that PQ is therefore a half of FE. FE is equal to B, is a half of FE. Hence, PQ is parallel to FE because they are multiples of each other. Very, very difficult sorts of questions we've got here. And that is it. Oh my gosh. I have to say vectors are some of the toughest questions. I mean, if you're getting through this, then like you really are aiming for an A star. Not an A star, a grade 9. What I would like to say is that there are a lot of marks here. And when you look, you can just get a mark for starting things off. Like in this particular question, you can get 2 out of the 5 for just finding out what OM is. So that is just finding out, like, you've got AB, finding half of that, and then going up there like that. So you might not be able to do the whole thing, but please make sure you do just get yourself some of the marks by using some of the information in this question. I am relieved that vectors is over. That is until you get to A level. If you found it useful, please do like the video, please do subscribe to the channel, and wishing you the best of luck with all your revision.